All right, welcome to lesson 3 on square roots and cube roots. I want you to not get too wrapped up in this because quite honestly, you can always use a calculator to calculate square roots and cube roots. So if we're looking at real life, you're not going to use this a ton. So watch through this video, but again, don't get too hung up in it, but I'll just talk about how you can use prime factorization to calculate square roots and cube roots. So just before we get into that, so just a reminder that a perfect square is any whole number that really where it comes from is if it can be written as a square with side length. So for example, 5 times 5 gives me an area of 25. So the number 25 is a perfect square, right? Because 5 squared is 25. So that number there is the perfect square. Okay, a perfect cube comes from a volume. So if I had a cube that is 4 by 4 by 4, so 4 cubed is equal to 64. The number 64 is called a perfect cube. The square root of a number. So if I'm asking you to find me, so the square root of 36 is 6, it's saying what multiplies by itself to give you 6. The cube root, which is the cube root of a number, the cube root of 125 is 5. That means that 5 times 5 times 5 is 125. And what we know is that squaring and square rooting are opposites, and cubing and cube rooting are opposites, okay? So if you wanted to make a list, you could down the side here of numbers that are perfect squares. I will just start it. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So all these numbers here are perfect squares. Over on the other side of your paper, if you go 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on and so on. So you can kind of fill down for quite a while there if you would like to have those numbers handy. If you're not sure how to enter in a square or a cube on your calculator, just hit pause in the video right now and call me over and I can help you. Okay, so we can use, like I said, the prime factors to determine the square roots and the cube roots. So our process for that is that we will write the product number as a product of prime factors, as we have done on basically everything. Then for square roots, we're going to group our factors into pairs. And for cube roots, we're going to group our factors into trios. Okay, and then we'll go from there. So starting with the prime factorization of the number, say 1296. So again, we know that that's even, but I'm actually going to jump ahead a little bit just because I want to make these factor trees a little bit shorter. So I'm going to say that this is 36 times 36. That makes this 6 times 6. And this is 2 and 3, 2 and 3, 2 and 3, 2 and 3. So if I write that out, so I can just write out my factors, and I'm going to write them kind of in order. So I have 1, 2, 3, 4 twos. So it's 1, 2, 3, 4 twos, and 1, 2, 3, 4 threes. This is a square root, so I'm going to group into pairs. So 1 that are the same. And then to answer my question, the square root of 1296, I will take 1 from each pair. So 2 times 2 times 3 times 3. And that gives me 36. And you could check it with your calculator, to be quite honest. Cube roots. So if I want the cube root of 1728, so if we look at the factor tree for 1728, again, if I kind of want to speed this up a little bit, this is 36 times 48, which is 6 times 6, and 6 times 8, 2 times 3, 2 times 3, 2 times 3, 2 times 2 times 2 is what A is equal to. So if I write out my factors, so I have 1, 2, 3, 4, 5, 6 twos. 1, 2, 3, 4, 5, 6 of them. And then I have 3 threes, 1, 2, 3. And since this is a cube root, I'm going to make trios. So I need 3 of them. So the cube root of 1728 is, again, 1 from each of them, 2 times 2 times 3, which is 12. Okay, I will do one more example. If you don't need to watch it, feel free to skip ahead if you think you got it. But 1764, I'm going to break that to, I think, 4 and 441. So that will become 2 and 2, and then 441 breaks to 3 and 147. 147 divided by 3 is 3 and 49, and that becomes 7 and 7. So if I write the number 1764 with my factors, it's 2 times 2 times 3 times 3 times 7 times 7. So because I'm doing a square root here, right, I'm going to group them into pairs. Square means 2, cube means 3. So the square root of 1764 is 2 times 3 times 7. I take 1 from each, and that is 42. Okay, let's look at a word problem now. Okay, so this says use prime factors to determine if 1444 is a perfect square, a perfect cube, both, or neither. So basically, if it's a perfect square, I'll be able to write its prime factors in pairs. If it's a perfect cube, I'll be able to write it in threes. If it's both, I could do it in twos or threes, so you would need like multiples of 6, essentially, right? Like 6, 12, something like that, or neither. So start with the product of prime factors, so 1444. We're going to break that up into 4 and 361. This is 2 and 2, and I fought for a long, long while to find 361, but it breaks to 19 and 19. Okay, so the number 1444 in its prime factors, 2 times 2 times 19 times 19. So because I can group them in twos, it is a perfect square. Okay, I can't group them in threes, so it's not a perfect cube. So it is only a perfect square. Okay, determine the side length of the square below. So what I know is that the area of a square is side squared, right? So the area of this is 484. So to solve, like just like when the opposite of multiplying is dividing, the opposite of adding is subtracting, the opposite of squaring is square rooting. So I'm going to square root 484. So in all reality, like just take your calculator. This doesn't say that you have to use prime factors here. So we could just take our calculator and square root 484. And the square root of 484 is 22. So my side length is 22 millimeters. So 22 by 22 gives me 484. Okay, a cube has a volume of 4,913 cubic inches. What is the surface area? So this one is a little bit trickier because if I want to find surface area, I need to know the side length, right? So it gives me the volume, and over here on the side, I said the volume is equal to side cubed, right? So kind of the same idea. Volume is side cubed. I know that the volume has a value of 4,913. And I want to solve for that. So again, it doesn't say I have to use prime factors, so let's just use the math. So s cubed, to undo a cube, you cube root it. So I'm going to cube root 4,913. Okay, so put that into your calculator. If you don't know how to do a cube root, call me over. But that is 17 inches is my side length. So this is a 17 by 17 by 17. So if I want the surface area of that, we know from before that it's 2 length width, 2 width height, but they're all the same. It's a square. So that means that my surface area is just 6 times the side, or 6 times the side squared. That's right there. So there'd be 6 that are all the same side. So 6 times 17 squared gives you 1,734 inches squared. Okay, so those two are a little bit trickier, but I'm not asking you to do prime factors there. So I want you to go ahead and work on the practice questions. And when you are done that, then we can move on to the next thing.